This is my hometown. It's called Youngstown, and it's in the state of Ohio near the Pennsylvania boundary. In Youngstown, we make steel. We make steel and talk steel.
Hi, welcome into my channel. This channel is about astronomy. In this video, I discovered that the Big Bang is false, so I discover many things. Once you discover that Big Bang is false, many things will fall. In this video, I studied with some steel workers from 1944 from America, because I want to imagine together. I have some reasons why, but you must follow me, okay? So imagine together, what is the biggest sphere of iron? This is copper of iron that you can make.
Next door, Tommy Hughes is giving one of the furnaces a drink of hot iron from the 35-ton ladle. This iron is fresh from the blast furnace.
Pure iron, nothing else, only fear. Like in Mendeleev, fear. Iron in English, fe. So big ball of iron, how big it could be? The Earth dimension size, let's say, but only iron. But a sun dimension, but only iron. Like the Earth has 4,000 kilometers in circumference, like this, 4,000 kilometers, this circumference. But the sun has like 1,000,000 kilometers, 1,040,000, like, let's say. So can you have it? Can you have a sphere like the sun dimension, only iron, but a bigger one? Can you have it? This is, you understand, it is a nice thing to do, like a mental experiment, Gedanken experiment.
This is the ore. It looks like dirt, but in a few weeks it'll become part of a ship, a tank, or a gun. And in peacetime, an office building, a bridge, or a dam structure.
So mental experiment, imagine 10 times the sun, 3 times, you can have a big ball like sun-earth distance. Can you have it? But why not? If you imagine this, why not? If it is going to be possible to have this big piece of iron, like it is 150 million kilometers, one astronomical unit, Earth sun distance. Can you have this?
In the blast furnace, the boys smelt the ore into iron, the first step in making steel.
So you understand this mental experiment, how big a sphere of iron can you have? But now let me tell you what I made this mental experiment. For you to understand that the sun is made from iron. The 90% of the sun is made from iron. They are learning that it is made from hydrogen and fuses through non-known processes hydrogen in iron, that it does not exist. But let me tell you on short, you give them hydrogen, a big ball of hydrogen in space, but nothing else, and let them to produce light only from hydrogen, because they cannot make. You need 2 elements. But so let the sun aside for now, and imagine what I want to tell you. Iron, if we have a big ball, if you put it here in the microwave, that's where I brought this microwave. Let's say you have a big ball of iron, you put it in microwave. What will happen? You know, it will produce sparks. It will produce sparks. And a copper, maybe. So you put at your home like a big ball of iron in your microwave, and you microwave it, okay? It will produce sparks. You see, do not do this at home, like that stuff. I say like reverse. You do this with your own apparatus. You put a spoon, like a teaspoon of inox in your microwave, so it will sparkle on sure. But now they are saying that there's a microwave background radiation. So what does this to the sun? You must understand this is the source of the sun ignition. The microwave background radiation. It converges on a big ball of iron and ignites it. And you cannot know what the ends of the life of the sun will be, because it always, when you have this electromagnetic microwave radiation, you will ignite the sun. The sun does not have like batteries producing through internal processes. It is connected. You understand? So you cannot calculate the termination life of the sun through internal properties, because it is alimented, it is microwave. So you cannot deny this. But I want to take on this opportunity to teach some crazy scientists that are actual day scientists many things. You see, these guys are honest workers from 1944. They will tell you these things. The temperature is a limited function.
Molten iron comes out at 3,300 degrees.
The temperature is a limited function. Iron melts at 330 degrees, he says. All the Mendeleev atoms have 5,000 degrees. You have some ceramics, a combination, molecular atomic combination. You melt them at 5,000 degrees. 10,000 degrees, if you modulate some frequency of energy, and in some condition you may obtain 10,000 degrees. So how they calculate 1,000,000 degrees in the sun or in the stars? They are crazy. These guys that were honest workers knew much more science than these actual current scientists. So again, they tell you that the temperature is a limited function.
These boys are slagging, lining a furnace with dolomite. This protects the wall of the furnace against the extreme temperature.
The temperature is a limited function. So if you understand it in an easy way, you cannot bring the microwave to produce more than 10,000 degrees Celsius. Let's say 20,000, 30,000. So you understand. So I've told you many things now, but I'm telling you, the microwave background radiation is produced by the clouds that are at the border of our galaxy, 1D with the speed of light, and they are like in a circuit from a pole to a pole, from a pole to a pole, and they came across like this through all the solar system. It is a combined field with a microwave background, electrical field, and light field. Combined field. This is the cause of the gravity, not the sun. So now you understand that when we put a big ball of iron in this, it will ignite at once. I've told you many things. Like you see, iron melts, it has light, can support light, and has a relation between iron and light. It is known, okay? So now you understand how fast you ignite light. Look. How fast do you ignite light? So you can ignite the sun, the entire sun in one day. Like in the Bible says. This, I wanted to tell you, supplementary. So why? You have a big ball of iron and you electroshock it one day. You electroshock iron ball of iron. What? You will melt it, partially melt it. You make the electromagnetic fields, you see them on the sun, that they are flowing. It is like a magnet. It is many ions of iron. Even NASA film it in many ions of iron. So you must have other few materials, because you cannot produce light only in the difference of potential. But you must have only already two atoms. So how do you produce only from hydrogen? Light, you must have only necessary two atoms. Okay, so this is the way I'm filming myself, this is the way I make my videos. If you understand, I'm saying like a coffee science, tea science. I always have here a cup of something to drink, tea or coffee mainly, and I'm filming myself like not straight, and I like this, not for other reason. This is the way. From someday I will film myself maybe perpendicular. So many things these guys are teaching you. They are hitting a piece of iron to understand the breaking force point of iron. The iron has a breaking force point, like they did it on material engineering science. This is, this is believe me or not, this is iron still. So you can break it. You see these guys hit with a hammer and they break it.
Mike's people came here from Czechoslovakia. Earl's ancestors came from England in the 17th century, when there wasn't much to America but a few colonial villages along the coast. By inspecting samples of the molten steel, the boys can tell exactly when the furnace should be tapped.
They did on all dimensions, like this thick steel, double thick, double, triple thick, and they observe when you will break this. When you will break this. So you now understand that the atoms have a breaking point, but if you arrange the atom differently, you combine it with another metal, with copper, like let's say, like this, you do not know, you but they already did this on engineering science, with material that you can produce in some condition, like earth condition in the factories. But if you put them like in electromagnetic fields, you cannot know how alloys can be produced. So the strength of the breaking point of iron is different. We do not know this at current day. You can make some alloys at electromagnetic frequencies between copper and iron, and the melting points will different, the breaking points on area. But why I'm telling you this? The sun rotates like this. So if it is made from iron, it is not made from hydrogen. They are tricking you. It's not made from helium. It has some helium, but it made. So if you spin it like this, because this is gravity, I tell you. When the centripetal force will go in the middle and will obtain this breaking point of these guys, the sun will be cut in half.
Mike's people came here from Czechoslovakia. Earl's ancestors came from England in the 17th century, when there wasn't much to America but a few colonial villages along the coast. By inspecting samples of the molten steel, the boys can tell exactly when the furnace should be tapped.
Exactly in the middle, by the centripetal rotating force and centrifuge force. So in this way I'm telling you that you cannot obtain a black hole. And a ball of hydrogen has some smaller connection at the breaking point. So you imagine you rotate a ball of water in space, you will be cut in half. You obtain half a ball of water smaller in half. The atomical connection between hydrogen and oxygen are more than this iron piece. Breaking point. So if you have a ball of pure hydrogen, liquid hydrogen, you rotate it, you spin it, you'll break it faster than this. So you cannot obtain a black hole. I've told you many things. These crazy scientists are more stupid than this worker from 1944. They were not stupid. They were very smart. Okay? So these guys are stupid. That guys were smart. And they are presenting you science. This is the way the science looked. Like these guys did it in 1940, okay? So goodbye, God bless. I've told you many things. Maybe I will make another video with these ideas, because it is good to imagine how the bigger ball of iron you can have.